Hi everyone, I'm going to take you through today's webinar. So it's on data science for nutrition. So a little bit about me. I'm the food nutrition scientist here at Crown Global. My background is nutrition. I've probably spent the last couple of years in research and working on various projects. For today's webinar, I'm going to talk a little bit about Crown Global and what we do here. I'm going to focus on food consumption surveys, as these are the main sources of data here at Crown. I'm going to talk about predictive modelling in nutrition, some case studies, and then finally our tool, Crown Nutrition. So a little bit about us at Crown Global. So we are a data science technology company, and we work in all kinds of data, so not just nutrition. We have a mix of backgrounds and disciplines, so software, maths and stats, food and nutrition, but I suppose our three main areas would be food, personal care, cosmetics, and chemicals. So our mission is a world where everyone can make better decisions using data and expert models. And our services include technical services and scientific projects, data science tools and patents, data management, and predictive modeling. Okay. So, data and nutrition and food consumption surveys. So really, as I said, these are our main sources of food nutrition data here in Crown. And so these are surveys that are conducted normally on a national level, and they collect data on what populations consume in terms of foods and also then their nutrient intake. So I'm briefly going to discuss what they're used for, what data is collected, and some kind of methodology considerations, maybe some limitations as well with them. So why then do we collect this data? Well, I suppose monitoring what people consume forms the backbone of food and nutrition policy. So once we have this information, we know what foods are consumed, we know energy and nutrient intake in the population, we can look at trends in the population, so who's under-consuming, who's over-consuming, different nutrients or energy, what foods are contributing. We can also look at exposure to potentially harmful substances. So this information then is used to inform public health policy, food safety, and then also used in industry. So we use this, the industry would use this data to examine how their products contribute to nutrient intake and also to model the effects of potential new products that they might have. What data then do we need to get this? Well, we need to know consumption data, so what foods are consumed and how often they're consumed, and we also need to have composition data, so the energy and nutrient composition of those foods. So I'm going to talk to you a little bit about these two areas now. Okay, so consumption data. I'm going to briefly describe how we measure food intake. So measuring food intake is complex, and really our aim in general is that it should reflect habitual intake. It's self-reported and prone to error, and therefore important to understand the methods used and any limitations behind these methods. So when we're measuring food intake, we can look at indirect measures, where we don't take consumption directly from households or individuals, or we can use direct measures. Indirect measurements, we can estimate food or nutrient intake by looking at national food availability, product level supply data, or food purchased in a household. And then our direct methods, really what we're most interested in, is it gives us the most flexibility and the most granular data for modeling later on. Different methods, and the most common ones used would be weighted or estimated diaries, where we ask people to complete a diary over 3 to 7 days. The 24-hour recall, which is a diary, or the food frequency questionnaire as well. So as I mentioned, there's different limitations and pros and cons of different of these methods, so it's important to take these into consideration before you're looking at your data. So the weight diary, for example, is carried out over 3 to 7 days and probably gives us the most accurate portion measurement, but it is time-consuming and burdensome for your volunteers to complete, and then it may cause your participants to change food habits. You have to question as well sometimes whether your participant or person completing it is representative of the population. They might be more health conscious, they're literate, etc. The 24-hour recall then is a low respondent burden, does require literacy. But if you're looking at one recall, this may not reflect habitual intake. It requires skilled interviewer and reliable memory and may lead to over or underestimation of different foods. And then lastly, food frequency questionnaire is low cost, it's a low respondent burden, but it relies on memory. It isn't, the portion sizes might be precise or quantified, and they are also population and cultural specific. So they need to be validated in the population that they're being used in. Then our composition data. So we use this to convert food intake into energy and nutrient intake. These provide energy and nutrient values for the foods listed in the survey, and ideally they're coded and they're linked back straight to the survey, and they can be based on lab analysis or are estimated from other data. So having good quality composition data is vital. We have many different stakeholders involved in compiling and using these databases, so they do need to be good quality. So as I said, they can be compiled directly and using lab techniques, but obviously it's not possible to do this for every single food. So you usually compile both indirect and direct techniques. So when we're indirectly, we can use other original analytical values. We can impute them from another food or similar foods and calculate based on recipes. So our indirect data then we can use averages or point estimates. Obviously averages are not always reflective, so we can use distributions, and these distributions can be empirical or parametric. And as I mentioned, the sources are usually publications or reports. We can also use proprietary data as well. So some composition data examples. So the USDA is a common one, the Council Wisdom in the UK, and then the Chinese Food Composition Database. And so as I said, these vary considerably in their structure and also in their quality. So some are linked directly back up to their food intake data, so into the survey, others are not, and some are still paper-based, so these offer different challenges, and you need to consider these as well. And then lastly, we also can surveys can also collect data on their individuals. So these can include demographics, so things like age, ethnicity, socioeconomic status. We can also take phenotypic measures, so anthropometry like height and weight and blood pressure, or biofluids, so we can look at the traditional clinical chemistries like blood counts or total cholesterol, or these plasma and serum can be applied for omics techniques, and there's some really interesting studies coming out in this area. So the general structure then, we will have each subject will be given a unique ID. We know what they consume. These foods are given a food code, which then ideally is linked back up to the composition. The food codes are also generally grouped, but we can, if we have the data and it's flexible enough, we can regroup and do different things with them as well. So some limitations and considerations. So as I mentioned, the data can vary in quality and structure. And all these techniques are all ways of collecting food intake data. These are self-reported. And there is a need for objective biomarkers of nutrient intake. So there is some really interesting studies going on in this area. So hopefully more will come out in the next few years and we'll have these objective markers. The studies are expensive and they're burdensome to complete. And some are completed on a rolling basis, some are a bit more random. So the data can be quite out of date by the time we get it, but it's still very valuable. We need to use it. And there's also problems with access to data as well. So we might not always have the access even though we know the database exists. So one way then of overcoming this was maybe to use online web-based technologies to collect dietary intake. So here at Crown, we've developed this tool called Crown Diet. It's a way of collecting 24-hour recall data. It might be suitable for using large cohorts or if you have multiple locations. And it could also be used as a potential way of collecting intermittent data between national surveys, for example. And this was based on a project called Foodbook 24, which was developed in Ireland and used to collect dietary data from Irish adults. And what's good about this is it's linked to a valid composition database. Not all online techniques would be, and has also been validated in Irish adults against a semi-weight food diary as well. Then lastly, the Extra Comprehensive Database. So this is a really useful database to use. It provides summary statistics of acute and chronic food consumption in the EU, uses the Food classification system of around 160 foods, and provides statistics of food consumption that are reported in grams per day and in grams per kilograms body weight per day. It covers both infants to adults, 75 years plus, and considers all subjects and consumers only as the link is there to it. And then other alternative data sources we can use on top of our food consumption surveys include market research, and so things like Cantor and Euromonitor, and I'll briefly discuss a case study where we use Cantor data later on. We can use crowdsourced data, or as I mentioned before, there's online data gathering tools as well. So next, I'm going to talk about predictive modelling and how it can be applied in nutrition and specifically within the food consumption survey. So predictive intake modelling in nutrition, why do we use it? Well, it's used to inform product development, to ensure consumer safety, for public health policies, and to use historical data to predict outcomes. We can also use it to assess consumer health and product safety ahead of running studies, look at the impact of a process or product change to determine optimal nutrition and product safety. So some examples would be to examine the effects of changing portion size, the effects of reformulating or fortifying products, or the effects of replacing the food with different foods. So how does this work? We have a person and we know what they've consumed in a day. We can look at different scenarios. So, for example, we could take a food and we could look at what would happen if we reduced the portion size. And we could take another product like bread. We could see what would happen if we reformulated, like reduced its sodium intake. And we could also look at what would happen if we swapped a food, like say this ice cream, for another type of food. So then we can apply this to one person during one day, but we can also look at what happens across several days and across each person when we apply these scenarios, and we can get our daily average then. Then some case studies we've done here in Crown. So the first one I'm going to talk about was with FDI. So this is Food Drink Ireland. It's a trade association of the food and drink companies in Ireland. So their members have made significant effort to reformulate products in recent years, and this is an important step in tackling public health issues. And so we aim to see the impact and to quantify these reformulated products on the Irish population. So we looked at 600 products from 14 FDI members and examined how this impacted energy intake, fat, saturated fat, sugar and sodium. We collected sales and nutrient data from these companies at 2 time points, so 2005, which was pre-reformulation, and 2012, which was post. We also used market share data from Cantor, which was used to apply weighting to these reformulated products. The dietary habits data came from the national surveys from adults, teens, children and preschool children in Ireland. These surveys were carried out by IUMA. And we compared nutrient intakes in the Irish population at these key time points by nutrient information from these products into the survey data. So when we look at some results then, so this is looking at an optimistic scenario in food consumers only. So we can see a big percentage reduction in sodium intake, and then for adults this is up to 45%, implies that their reformulation efforts had an impact on intake. Another project then that we worked on was the Odin XP7, and this was examining food-based solutions for optimal vitamin D nutrition and health throughout the life cycle. So it aimed to model the impact of changes in vitamin D content of the food supply and vitamin D intake, and also on serum vitamin D in EU citizens. So I suppose vitamin D deficiency is widespread across Northern Europe and has a significant impact then on human health, affecting growth and development and health problems in aging as well. So in this project, we are looking at how biofortifying foods would impact on vitamin D intake. So we increased our vitamin D in eggs, say, from 3.2 micrograms to 6.7, and across the different products as well. So our original intake then in UK adults, this would be 4.1 micrograms. When we apply the biofortified eggs, beef and pork, we're getting up to 5.1. And when we apply all the foods, we're getting up to 9.8, which will be just about recommended intakes. So this is quite interesting. So again, we can see these results here and looking across the different percentiles of consumption. We are then also interested in looking from a stage perspective. So what would happen if we applied a 50 microgram supplement? We increase the supplement to 50 micrograms for people who consume supplements. And as we can see, we're getting quite high intakes for vitamin D, or for our median, it's still below 10, but once we're going over the 75 up to 97, we're getting quite high intakes. So this was quite interesting to look at in terms of safety as well. And then lastly, our case study was looking at new products and predicting health outcomes. So this project aimed to model the impact on nutrient intake and on blood pressure by replacing milk with a milk fortified with potassium. So we were looking at Chinese adults aged 45 who were milk consumers. We looked at potassium intake before and after scenarios and how this then affected blood pressure. So our mean intake before the intervention then would have been 1,781 micrograms per day, and then this increased to over 2,000 milligrams per day. And when we look at blood pressure then, we're seeing an effect on blood pressure. So when we're looking at systolic in the total population, we're seeing people moving from a pre-hypertensive in both conservative and optimistic scenarios into the normotensive group, which is good. And when we look at product consumers only, so for those who are consuming the milk product, we're seeing a bigger increase from people who are pre-tensive into this normotensive group again. So then lastly, I'm going to talk about Crown Nutrition, R2 here. So it's a unique online dietary intake analysis tool which utilizes pre-installed or the user's own data used to assess nutrient and food intake and the impact of changes in formulation, portion sizes, food replacement in populations across the globe, and to be used in a fast, streamlined and easy-to-use manner. And so issues we can solve, so we can look at consumer intake analysis and nutritional adequacies. So who is meeting recommendations or who is under recommendations. We have global data sets, so from the US, EU, and South America, etc., or we can also use your own data, and then we can use the data to make decisions on new product development, optimal product formulation, and portion sizes. So then we currently have data on the US, in Brazil, the UK, Israel, France, Mexico, China, Ireland, and the Netherlands. We also have data on Belgium, Italy, Spain, and Denmark, so this requires submission based on the cost that would be used. Okay, so thanks very much for listening. That's the end of today's webinar. So if you have any questions, you can use the toolbox here. You can contact us at info@crownglobal.com, or my email is rebecca.barron@crownglobal.com.